Good morning, one and all present here. Myself, Dr. P. Janagaratnam, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology. In my previous video series, I already discussed about the different topics which is related to the mechanics and machines and basics of kinematics and all. I already discussed. Today, I am going to discuss about the new topics and Unit 2, which is related to the CAM design. First of all, the basic needs of cam and follower and what are all the basic types of cam and followers are available, and the cams with special contours and all. Today I am going to elaborate. So first of all, what is meant by cam? A cam is a rotating machine element that imparts the reciprocating or oscillating motion to the follower. Based on the cam rotations, the follower will be moves through the either forward direction or reverse directions, which will move through the upward or downward directions. It forms a higher pair with the follower, converting the rotary motion. We are giving the cam, which will be an rotary motions, which will be converted into the another types of motions. It is very essential in the engines, automations, and machineries for the precise motion controlling purpose. So why we are going for a special contour means the manufacturing challenge. First of all, the standard cam profiles can be complex and costly to manufacture and simplified production. Special contours use circular arcs and straight lines for easier machining, and the reverse design specify the cam shape first and the drive follower motions, inverting the traditional process. By using the traditional process, we have to make these kind of cam and follower. So tangent cams with reciprocating roller followers, which will be used for our reciprocating engine mechanisms. Flanks of the cam are straight lines tangent to the space or the nose circles, commonly used in the inlet and exhaust valves of the internal combustion engines. I already told, which will be used in our IC engines, and linear motion phase, which constant velocity characteristics, and the transition phase, which will be controlled with the acceleration profile also. In our previous class, we have to discussed about the velocity and acceleration of the reciprocating mechanism. Same kind of things will be followed this also. So this is the some of the types of special contour cams, circular arc cams and tangent cams and composite cams. Circular arc cams means these it is very smoothly for the continuous motion, and the tangent cams, which will be straight flanks tangent to the circular arcs. Composite cams, which will be the combinations of both arcs and the lines, and specific motions profiles can be obtained. These types reduce the machining complexity while maintaining the functional precision value of that contour machining process. So this is the motion characteristics of special contour cams. Motion means first the rate of change of distance with respect to time, which is called known as displacement. The follower motions positions can be analytically derived from the contour geometry. Velocity, the rate of change of displacement with respect to time. Constants are the straight flanks reducing the dynamics loads, and the acceleration, which will be controlled transition and the minimized wear and vibrations. So the special contours allows the predictable motions with the controlled accelerations. So it can be mainly used to reduce the wear and extended the compound life. We have to reduce the wear means automatically it can increase or extend the compound life. So this is the manufacturing costs and benefit of the special contours. So simplified CNC programmings for no coding process will be used to make this kind of command profile, and lower tooling wear and the faster production cycles and easier for the quality control. Geometric simplicity aids inspections, and industry adoption, which will be used for an automation process. So the real world applications of the special contours are the automotive, like inlet and exhaust valves cams in the IC engines, packaging machines, repetitive precision motions for the high speed operations, textile machineries for controlling the needle and subtle movements. Here we have to use some of the fluid power components also to control the valving as well as the component movements, and robotics for the repeatable and smooth actuation sequences for the making or to reducing the employer works. So this is the real world applications of the profiles will be used. This is the some of the design considerations while designing the special contours, like first one is for material selections and optimization process, which will be used to maximize or minimize the functional values, and dynamic analysis and the back trade-offs. So drive efficient motions, the special contour cams, first one is for making the complete balancing system and critical role in the automation system. Understanding the design principles empower the mechanical innovations. So this is the some of the components which will be used, like coincident joints, multiple kinds of joints and shares the same locations. So coincident joints occur the two or more joints physically connect to the exact same point or along with the same axis, and constraint impact and mobility implications. Mobility, the degrees of freedom will be also to be considered. So this is the today's class summarizations. Today in this video we have to discuss about the CAM. What is meant by CAM? What is the purpose of using CAM in the mechanical applications and real world applications, and what are the basic types of CAMs and the design considerations of the CAM, and I'll discuss. This is the assessment quiz based on this session, and this is some of the reference followed to make this kind of PPT for the CAM design, special CAM design contours. Thank you. Next video I have to discuss about the another CAM terminologies and other topics. Thank you.